Well, hi, good morning. Thank you for joining me in my shop. Today is January 18th. A little bit of snow coming down outside. It's 0 degrees, but by the end of the day it's going to be like minus 15 or something like that. We're going into a real cold spell here, which is normal for this time of year. There's nothing unusual about that. Okay, so today I intend on doing the FM alignment, or at least checking it and trying to improve it with this radio, and I just want to let you know it's on the fringe of my experience and capability, so I'm liable to stumble around a fair bit while I'm doing this. Not that that's that unusual either, but that's it's a warning. If you're going to watch my video, that's a warning to you. Okay, first thing I'm going to do is I'm going to stop and reread the FM instructions before I start it all. Okay, first step is to remove the positive lead of the detector capacitor, which is this guy right in here. And the positive lead's just coming over here. It looks pretty easy to do. I'm going to give it a go here. Oh my. Oh. What am I seeing there? Let's just take a closer look at this. Okay. Yes. So when I'm looking at this with my eyes, I really couldn't see the separation between this terminal I'm touching and the one the wire goes to, because it looked like the wire is soldered to this first terminal. No, it's up in behind there. Okay, making sure I'm seeing what is really there. Yeah, I can see it now quite clearly. So I'm very likely to replace this capacitor in any case. So cutting off one lead is not really a big deal. Let's just shorten this up. Just in case we do, just put it back. And I'm going to test the capacitor. This radio is full of high quality parts. I think that's typical of Heathkit. No wax capacitors in here, except these molded ones here could actually have a wax capacitor inside. So we're going to test this guy with, oops, we'll use this tester here. Okay, what do you say? I'm not even sure what it's supposed to be. Bigger capacitors take longer to test. Ooh, this is a long time. Oh, 37 picofarads. Well, I think maybe I was making and breaking contact here, or something like that was going on. Let me try a better grip on here. The noises you're hearing in the background, by the way, are my cats goofing around. Let's go right on here. I'm quite curious about what they're doing, but I don't want to look. Taking a long time again. "36 picofarads. Well, that's not very good. Based on that, this capacitor is really short. That should be like, I don't know, 5 or 10 microfarads. Shouldn't it? Let's just take a look and see what it... in fact, I'm just going to take a look on my own here, because I can quickly get to the schematic. And this capacitor is supposed to be 10 microfarads. It sure looks like a 10. Might as well cut it right out of there. Wow, that's really bad. In fact, before I do that, let me put a reminder clip lead here. So I don't forget where this came from. "10 microfarad, 25 volt. C2595. I should put the number on it like that. Looks perfectly fine. Let's test it again. Seems a little quicker this time. A little wee bit quicker. Okay, not quicker. Notice that battery test was 8.8 first test. What? So that's how bad this thing is. Really having trouble believing this. Let's go to the other type of tester I have for capacitors. And it's really not the best one for doing electrolytics, but if this electrolytic is this bad, we should be able to spot it here. Let me just climb over things. Oops. Stay like that. To flip this switch, now the unit is ready to do a electrolytic capacitor, so its calibration is a wee bit different. This time I have to pay attention. The positive lead is in the center here, and you have to pay attention to that when you do electrolytics on this testing machine. This thing's only a 25 volter. Oh, that's a problem. The minimum voltage from here is 50. Well, we won't do the leak test. Let's not do the leak test. We'll try to measure the capacitance with this. Okay, so this is a big capacitor, 0.1 to 30. Okay, and we're seeing it open here. So right here, we'd be reading, this is 50, this is 10 microfarads, so we're reading about 11 or 12. The eye's not opening all the way, but I'm not sure that's well, here, it's because of this adjustment. Yeah. Well, according to this, it's correct. Maybe my other tester can't do this kind of stuff. Do I have another? I have another tester, but I have no experience with it. Should we give it a try? Why do I care? I'm going to replace this anyway. I mean, regardless of whether it's correct or not. Should I put 50 volts on it and see what happens? Well, I don't care much about the capacitor, so why not? Okay, so we're going to put 50 volts on this thing. Put this way over here. And we'll see what happens. Okay, so it opened a little bit. I'm not going to leave it there so it reaches the full charge. I don't think this capacitor is that bad. I think the test was misleading on that other tester. Can't be sure though. I do have some other capacitor checkers. I got this one up here. That's the one that I would tend to want to try. Well, I'm going to have some coffee and think about it. Why would I bother trying? Yeah, mostly gain some experience with that machine, but also what's going on with this? I put another. You know what? The thing to do is to get out a brand new 10 or something around that. This is 25 microfarads. Ridiculously large stock of low voltage electrolytic capacitors. Almost useless in my work here. Okay. A brand new 100 microfarads. What's it doing in the 25 box? 100 microfarads. Okay. Well, let's see what it does with it. So 81 microfarads. Well, that's pretty, that's close to 100. They're all hundreds. Let's try a big one. What's this? This is 2200 microfarads. Oh my gosh, that's huge. That's a huge capacitor. Certainly by tube radio standards. Wow, that's pretty close to 2200. So it's not having any trouble doing large capacitors. What did I do with it? Here it is. Maybe the third time's the charm, or is this the fourth time? If you're concerned about which of these leads I'm using, there's no concern. The machine figures everything out for itself. It takes a long time on this capacitor. Huh. Well, I don't know what to make of that. But clearly it's got to be replaced. I got enough test results here to force the replacement. But it's wise to replace that particular capacitor anyway. Of all the ones in here, that's one of the ones that's worth doing. Okay, but the tests are done with this capacitor out of the circuit. And oh, I can't leave this. Can't run this with this clip lead here. And probably hanging clip leads off of it if I use two. I'll have to find another way to mark this stuff. But now it's time for coffee before we really get going here. So I've been reading through the instructions for doing the FM alignment using a sweep generator, and they're vague. The instructions are very vague, and I'm not sure what to do. But in the meantime, my buddy is showing up here, so you want to go on there, do you? Careful, man. What are you doing? Oh, that's what happens with a cat. No destruction occurred. Lucky. Yeah. So instructions are vague. To me, they're vague. So I think what I'm going to do is I'm going to read the instructions for the actual sweep generator here, which are not vague. I've gone through them before. Yeah. So I think, the IF alignment's a fairly simple process. You feed through the IF frequency, 10.7. You just use a fixed generator and feed it through the IF. You could do it stage by stage, or try to feed them all at once, or adjust them all at once, whatever you want to try. The book, the instructions are sweep generator there. So I don't have a sweep generator that'll sweep 10. My sweep generator is sweeping up at 100 megacycles. It's sweeping at the regular antenna frequency, if you like. So, I could do 10 into the IF and have the sweep going on the antenna connection. I'm not sure that's helpful at all. Yeah, let's look at the instructions here. So here they are. So the vagueness is complete FM alignment procedure using a sweep generator, comma, marker generator, and oscilloscope. So they're envisioning three pieces of equipment. So connect the sweep generator this way. Sweep generator, well, what about the marker generator? Where is that supposed to be connected? Why, I assume it's the same place. Is it? Probably. Why are you hooking up a sweep generator on pin 9? So the sweep generator is running at the IF frequency. So you're sweeping the IF with a marker. That kind of makes sense. And you can get this kind of diagram. I don't have a sweep generator to sweep 10. I can do 10.7 with a fixed thing, and I can sweep 100 on the antenna. If I sweep 100 on the antenna, wouldn't you get the same result here? Or are there other alignment issues that would make that impractical? I don't know. I don't know the answer to that. Then I would move the 10 through these 3 tubes, or rather, for my, the radio's probably aligned fairly closely, so I could just kind of put it through the first one. What would that be? Do audio jack. Well, this is something. Oh, this is a different test here. Just these 3 here. Oh boy. Top slug, top and bottom, top and bottom. What are you trying to do? You're trying to get the marker in the center and then get this. You need the sweep if you want to try to get the sweep shape. That's all. Okay, I'm going to drink some coffee and think a little more about this. Okay, I don't think this is going to work out for lack of a 10.7 sweep. But I do have the sweep generator connected to the antenna. It's going to run at 100 megacycles. That'll put a signal into the radio. And here I've got another signal generator connected here. It's this one, this generator, and it's set to 10.7. And somehow in the back of my mind I'm thinking I've got a crystal controlled 10.7 in here somewhere. And one of these pieces of equipment can offer that. I wonder if it isn't the FM signal simulator. It's been a while since I've used it, so okay, I've got a cable here I don't need. Let's get it out of here. So the oscilloscope, the bottom line on the oscilloscope is looking right here across this resistor that's in the detector. Should give us the shapes, but only if the sweep is doing its thing properly. Oh my God, there's so many ways this can go wrong. For some reason my sweep generator is showing. Yeah, we're good there, I think. I don't know. I'm muttering and mumbling. This is not switched on yet. Just make sure all the equipment is connected first. Okay. I don't know what else to do here. Let's turn on the receiver and see what happens. Yeah. Okay. So we've got 109 volts here. What do we want? We want to look at the scope. Let me switch to the other camera to get a little better view of the oscilloscope, even though it's a little bit on an angle here. So the lower channel is the one that's not hooked up to anything, Jim. You never plugged anything into it. For crying out loud, look. Yeah, I'm not going to get too far like that. Okay. Well, we got something coming on here. What do you make of that? I don't know what to make of it. Okay, so we haven't got the radio tuned properly or anything as far as I know. So let me just flip back here. Until there's something more interesting on the scope. You can look at it this way. So we want this tune, want to wait. No, we're tuned right around 100. Let's see what happens. Okay, you can kind of see something going on there on the oscilloscope. Let me make it a little more sensitive here. Okay, I'm going to show you that because who knows what to make of it. Remember, I did warn you at the start of this video. There's bound to be a lot of fiddling around. So I'm tuning away from the station. And I'm tuning towards the station, towards the signal. Slowly tuning through it. Okay, I got a better view than you because my eye doesn't have a shutter effect. So why is it going like that? Why is it doing what it's doing? Oh, you know why? Because I don't have this set up properly at all. Not in the least. I've got the wrong kind of sweep going on it. Everything's wrong here. Everything's wrong. Yeah, so I'm using the internal sweep of the oscilloscope, and that's not correct. We want to use this ordinary transformer and set up a wobbler sweep, I guess we could call it. Let me turn on the transformer here. Okay, and we are connected here. I'll change this to this kind of setting. How come you're not going anywhere? Because it's not plugged in. For safety's sake, of course, I unplug a lot of stuff at the end of the session. Here we are. Ooh, that looks like we got way too much. Hey, now we're cooking. Have a look at this. Aha, look at that. So let's stretch it out a little bit. Make it a little bit brighter. Very curious. I can make it taller. That's not. We'll leave it like this. Well, it is roughly the shape we're after. Now, hopefully there'd be a blip in here, but it may not be. Like, I'm not using a proper marker generator sweep set machine. I'm using two separate machines. The result is you don't get a blip. You get interference patterns in here, but you can tell. You can tell. What can you tell? Let me change the marker frequency around a bit, and we'll see some stuff happen. We're seeing nothing happening. Nothing. I'm changing it around, and nothing's happening. So let me boost up the signal here. Oh, we can see something now. Do you see a little wiggle right above my finger? Watch the wiggle. You see it goes to the right, down the slope. Now it's going to go back up and get right to the top of the wiggle, or top of the peak there. And we got to do a number of other things, but potentially that is telling me what the IF is tuned to. If I look over now at my signal generator, it's 10.87. Nowhere near 10.7. The problem with this whole setup is it's very dependent on the radio tuning, I believe. So let me tune the radio back and forth and just watch what happens here with everything. So I just tuned it a little bit, and you can see the whole thing is moved off to the right. But my signal generator is still at 10.8, and it still wobbles on the peak. So I think that's quite valid then. You also see this funny bump here, which suggests an IF alignment issue, and we're only feeding the signal through one transformer right now. So that's quite a few things right there. Do I believe the setup is functional? That this is correct? That I can make adjustments now and line things up? Well, I think the answer lies in drinking some coffee. So I'm going to go and slug back a little bit of coffee, but I think we're on to something here. I think I can succeed. That's a bad thing when you think you know what you're doing. That's bad. Okay, here we go. Bottom slug of T8. So T8 is between this tube and this tube. Where is it? Wait a minute, there's nothing in there. No, I'm sorry. It's between this tube and this tube. It's right there. Bottom slug. Bottom slug. So, and what's this going to do? This is the last transformer. Just making sure I've got the bottom slug. I don't know. Let's watch. See what happens. What are you supposed to make of that? I mean, it's getting a lot better. Is that a good thing that's happening? The shape is terrible. What does it say? Let me just see what does it say? Adjust it for maximum? Hang on a second here. Let me just take a peek at the instructions. Here they are. For maximum gain and bandwidth, bottom slug of T8, approximate response. So every one is the same thing. For maximum gain and bandwidth. Maximum gain and bandwidth. Whew. I think the funny shape here, this shape is due to another transformer being out of kilter. Oh my gosh, what if I tune the radio a little bit? Yikes, let's do that again. Tune the radio a little bit. Now the whole show is going. What's the noise? I don't know. I'm not going to look. I get myself into trouble. Okay, we can make this less sensitive. And we can continue turning this. Oh my gosh, that's unbelievably. Look at that. Wow. Wow. Okay, let's go like this. Should probably turn down the input over here. Is probably really what I should do. It's not making any difference. Oh, but it is. It's not changing the shape. It's changing the amount you can see here of this. So maybe it's the output of the other one. Can I turn it down? I think it's down all the way. Oh, that's the bad news. So what I'm doing is I'm just adjusting the RF output of my signal simulator. I'm not expecting it to make this kind of difference. So probably the frequency is probably drifting a bit. So that's minimum. This is up a little bit. I'm going to tune the signal generator back and forth a little bit. Again, the shape doesn't change. But for some reason, this will change it. This is the RF output strength. Don't know what to make of it all, but somehow I've got this in the middle of the scope now, which is meaningless, I think. The main thing is the wiggly point is right up on top. Well, that's no good, because this is at 10.8, not 10.7. Okay, 10.7. The wiggly thing is traveling way up here. So we'll set this on 10.7. As if my arm's in front of the camera, I apologize. Okay, there we are. 10.7. The wiggly thing is right there. Somehow we got to get this thing on top of the wiggly thing. It's not going to get there. That's not going to happen. What could I be doing wrong here? Things seem pretty right to a point. I'm doing transformer 9, which is the last IF transformer. I'm not feeding into it the swept 10.7 with a marker. I'm feeding into the antenna, 100 megacycles. It's going through all the rest of the radio to get here. So it could be mucked up by earlier things. Because I'm on the last IF, earlier ones may be affecting the signal coming through from the antenna, which would not be expected if I were doing this per the instructions, because the signal would not come in through the antenna. It would come in right into the stage I'm working on. Okay, so we'll make the assumption that as we go along, it'll eventually move to the right. So what should I do right here, right now? Should I try to flip this one over there? So is this the real thing I'm changing here? This bump. Doesn't seem like it, does it? It seems to go over here now. So if that were the case, then this is where it should be, with this weird shape. And all this was because of earlier alignment issues. What do you want to do, Jim? 10.7 is really critical. Well, what we'll do is we'll do what we're supposed to do. We're supposed to line this up as best as possible at 10.7. That's about the best I can do. There's a little tiny bump there. Leave it like that. Move on to the next one. We'll just work our way through them all and see what happens. So now we're now got to reconnect the marker generator to pin 1 of V8. Pin 1 of V8. Okay, so I'm going to stop for a bit while I get this ready, and then we'll continue. Well, that only took a moment to move this down to pin 1 of V8, so that's what we're looking at now. I see another funny looking shape on the scope. Okay, so we're going to adjust the next transformer down. So we did this one, now we're going to do this one, and I think it says top and bottom slug. Let me check again. It says top and bottom slugs of T7, and what we're looking at is just sharpening up the shape. Sharpen it up. Okay, so we'll start with the bottom slug. Bottom slug, get in there. Okay, we're in the bottom slug. Wow, it's looking a lot nicer shape-wise, but I'm just shooting in the dark here. I mean, I could have turned this the other way. Let's go to the top slug. I'll push it through further. Okay, we're in the top slug. Oh, yikes. Oh, look at that. Now, how come we can't see the 10.7? I got this turned down too low. The 10.7, I think it's right here. Let's see, I'm going to move this around. Okay, so it's here. You can't see it, I'm sure. My hand's on the control. It's way over here now. It's right here. I can't seem to make it visible up here. Let me put more juice into it. Oh my gosh. That's a little much. Here, let me, since all the excitement is on the screen. Yeah, that's a little much. Let me turn this down. Okay, it's wiggling all over the place. So I think you can see quite clearly now. I can see quite clearly. There's a thing right there at the top. Okay, let's put this thing at the top and ignore all the rest of the nonsense. And we're at 10.78. So we're closer. I'm going to put this on 10.7, see where it goes. Where's it going? It's going right up 10.7. Hey, not bad. I didn't realize how little change of frequency here moves it a long ways. Okay, so 10.7 is sitting right here. So let's move that thing over there somehow. Can we move it over? Going into the other slug now. This will be the bottom slug. Oh yeah. Okay, don't know what to make of that. So I got modulation on this. Is this part of what we're seeing? Because I'm fooling around with the modulation on the. This is what we want. The sweep. I get the sweep is unimportant. Make it broader. Okay, that's interesting. So I'm trying to remember what this does now. This is increasing the width of the sweep. And so basically these two marks, the frequency that these represent is getting, they're moving apart. But on the screen they don't move apart, they sit here. So what happens instead of these things moving apart, this thing shrinks, it gets shrunk. That's what's happening there. So I guess we just put it in a nice spot like that. I warned you, 10.7. So 10.7 is sitting right on the top of this thing. Right now. That's actually not 10.7, but very close. Very close. Well, that's very close. If it's making you uncomfortable that it's not in the center, I can just do this. Ooh, lousy scope. There, make you feel better. So would that be it? That's it? The technique I'm using is what's probably the technique for the marker, or the second generator, is probably what's causing this thing to widen out so much. Probably. Okay, I'm going to fiddle with the slug some more. A little bit more. This is the bottom slug. It's doing nothing, which is really quite disturbing. Now it's doing something. Widening it out. We don't want to widen it. It said make it as narrow. Didn't say narrow. No, it said as broad as possible. Yeah, right. Okay, going in the upper slug. So this one it really favors this spot right here, which is the 10.7 spot too. Excellent. Okay, I think yeah. Yeah, okay, we're on to the next thing. I'll get set up. Just move the whole show down another IF stage and do it again. Okay. Oh. Okay, we're hooked up to pin 1. Turn this head on again, and first of all, the display rose up to this height, so there's some DC in here. I'm going to get rid of it. Like that. And I'm just going to center this a little bit. Sorry for knocking the camera. Now, there's a really weird looking thing in here. I'm going to move the 10.7 marker generator around a little bit. Aha! Okay, well, it's quite clear where this marker generator is showing up. I've got it set to 10.7 exactly. Almost. Yeah. Very hard to set this thing this precise. There we go. That's close enough. So conceivably, this is 10.7 right here. Okay, well, we'll start adjusting here and we'll see what happens. So now we're looking at the entire IF string. We're feeding the signal in at the start of the IF. I believe right at the start of the IF, right after the mixer tube. And we're looking at the signal as it's processed through every stage. Each stage we fiddled with to try to get something to happen. And when I look at the diagram here of what this is supposed to look like, just the same thing. Should just be a nice line coming up and going down, and the marker should be right at the top. It shouldn't look like this at all. But again, I'm doing this a little differently than what the book shows. Okay, so we're going to go into, oh, is it top and bottom? Top and bottom slugs of T6. Maximum gain and bandwidth. Okay, here we go. This is the bottom slug first. Make this just a little bit brighter. So I can see clearly the detail in there, but you can't with the camera. So you kind of get an idea of what's happening here. And we'll go to the top slug. It didn't really make any difference. So we'll just try to make it as uniform and symmetrical as possible around the 10.7. I'm going to go fiddle with the other slugs now. I'm going to go up to the T, whatever it is. This would be T8, I think. I'm trying to get in the slug. There we go. Because the bottom slug. This is the one that didn't do much. Okay. Top slug. Doesn't do much is a problem, you know. So it's the same sort of look to it, and I'll get it so it's balanced. It was just where it was. So I've aligned this in some way, whether it's an advantageous way. Okay, here we go. The very first transformer I did again. Oh, this guy has a tremendous effect. Not changing the frequency at all. Changing the response. I guess should I grow it downwards? I suppose. Okay, so now I've got the biggest response there. We'll go to the top slug. Goodness knows what that's supposed to be doing. We'll put it like that. That's a nice looking thing. It don't look very nice on the camera you're looking at, but with my eye, that's a pretty fancy looking thing there. Okay, what have we done? We've really done it here. We should listen to this thing. Did I listen to it ahead of time? I think I did, and it was picking stuff up. So yeah, we'll try it again. So and here's what I've done so far. So we're looking at the table of instructions here, and I've done these three. Measured across this resistor, always the same measurement point. Adjusting the different transformers. Bottom only on T8. Oh, did I fill with the top on T8 just now? And one thing keep in mind at least this is what I think when I'm doing alignment, I have no expectation of success the whole time. So I don't get disappointed because so this is what I've done today. I'm just going to leave it like this. Tomorrow, look at this weird stuff. 2 audio output jack, and we're getting a totally different sort of display here. I mean, it's a totally different ball of wax. We still keep 60 disconnected on this next test, but I'm not going to attempt that today. I'm done for today. And oh, we're going to listen to it. That's right, we're going to listen to it. It's just getting ready to hook up an FM antenna, just a wire, in fact. And I started looking at this more closely, what they've done here. So they have 2 wires sticking out. And these can be connected to the FM antenna to drive an internal FM antenna. What internal FM antenna? So we look at where these 2 gray wires are going. One of them goes to ground, goes to the chassis. The other one is this one. Comes over here. I gotta watch my finger here. This is switched on. I'm gonna give myself a shock if I'm not careful. Comes here. See this coil? This unusual coil sitting here, right in here. Look at the power line appears to be going through the coil. I can see the output of the power line after the fuse is on this little wire here. That's a pretty light wire going up to the transformer. So what they're doing here is they're trying to obtain some FM signal from the power wire. So if you don't have an FM antenna, you use the power wire as the FM antenna. You see how I've got it all bundled up over here, and that's not so good. Doesn't matter anyway, but this is what they've done here. Some other cheap radios, instead of a nice coil like this, they have a clamp. They have a metal clamp that just grips the cable on the outside. And sometimes you can see it on the outside of the radio. Sometimes the clamp is just screwed right to the antenna connection. The clamp is picking up the signal from the wire. If you got a radio like that, you need to have the power cord stretched out. And you need to fool with it and get it right. But we're going to use this piece of wire as an antenna. So I am going to pick this side here. And then I'm going to hang this up here. I'm going to hang it. This will probably make a sound in the microphone here when I do this. I'm hanging it on the microphone hanging thing. What is he talking about? I'm just hanging it way up there. That's the antenna. Okay. Wow, the radio could be operating. Let me put on the headphones here. Have you been listening to it all this time? No, I don't hear anything. Up with the volume. Okay, so I got to be very careful about copyright hits. FM radios, FM stations are playing music all the time. So I'm good for 4 or 5 seconds. Any longer than that, and YouTube will tell the owner of the copyright of the material that's been played, and then they'll make a claim, and they will take the $4 revenue, probably $4 revenue that my video will earn over the years. They will take it. Okay. And I understand and agree with the whole system. You know what? I've left this transformer plugged in. Let's unplug it before I forget. Okay. Let's listen to the radio. Hum when you tune between stations. Now that could be because the radio sensitivity's gone way up because there's no signal to make it back. So with it way up, we're hearing this hum. Dirt there.
Did deal with. Say the candidate had a plan. Say all of those things, panel. For a point, who
is this hypothetical candidate?
I believe that's Lex Luthor.
Possibly. Nico.
Theodore Hugbo.
Oh, I love that for him.
Look, he was half sunk in the water a little while ago, but he picked himself back up
Rallied.
by his
He's
bootstraps.
got that beautiful
Sure.
wife.
If that's not a
Yes.
metaphor for the Liberal Party, I don't know what is. Emma, who is
Well,
this?
knows about economics.
So we're listening to CBC. They've got a comedy program on, obviously. This is a mono signal. The CBC broadcasts FM in mono, not stereo. Just about every other FM signal is stereo, but this one is mono, and it's clear. The other ones were all fuzzy. This is signal strength is about the same as a signal just a little bit north of here, which we'll try again to compare. So stereo's throwing this thing off? That shouldn't happen, I don't think.
Yeah. I just dissociated, so I didn't say the last name.
I don't even know who he is.
Chris Siddiqui for the point. It is Mark Carney, the former Bank of Canada and Bank of England governor, soft launched his leadership bid on the Daily Show.
I think there's a good chance he'll be the next prime minister. That's music. Sounds like a lousy record player.
As you're calling it,
Let's go find that 90. So this is a station we normally listen to here, my wife and I, and it's clear as a bell on most radios. Why it isn't here, I don't know. Why would that be? Let me turn it back up.
It's time to Toyota. Lease a 2025 RAV4 LE all-wheel drive from $104 weekly for 36 months. 5.7% with $2,500 down.
To do with the stuff I was doing. Okay, I'm going to wreck the alignment.
Ontario Toyota dealer today.
Get ready to explore more at Georgian's virtual open house Saturday, January 25th. Connect through live interactive sessions. Learn about our programs. Talk with friendly experts about
interesting.
financial aid and student services. Need more reasons to attend? Apply and we'll cover the application fee for you. Plus, enter for a chance to win $5,000 towards tuition. Discover why Georgian College is more than an
Wow.
education. It's an experience. RSVP
That one
today
doesn't do
at
much.
georgiancollege.ca/open house.
Hey, we're going for lunch. We're going to Barry's Best Barbecue inside North Barry Market. We
Huh?
want to have real smoked brisket or pulled pork.
This
Shove it
top
on
one's the
bun
one that
so
really-
you can
really
shove it in your
throws it.
mouth. It's Barry's Best Barbecue.com. Through the weekend with Barry's Rock Station, Rock 95.
Even that. Good. Tune the radio. So that was a little bit of Pink Floyd there. My wife and I and our two sons are going to be going to see Brit Floyd. It's a British Pink Floyd cover band. Here they're going to be playing just 5 miles from my house here at a place called Rama, which is a casino on the other side of Lake Couchiching from where I am. If I look across Lake Couchiching, I can see this big hotel on the other side of the lake. And so yeah, Brit Floyd, pretty excited about that. That's in April here. Very excited about that. Okay, well, don't know why mono was clear and stereo was not. Stereo should be just as clear. I don't know what's going on there. Could be more and more alignment issues as we work our way through this. I'm bound to probably go through the alignment a number of times, up and down, in order to get this whole thing sounding good again. But I think the potential is there. I don't think there's anything particularly wrong here. It's just I don't have the capacitor in. If I don't have the capacitor in, there's no way the detector's going to work well. The capacitor's out during the alignment process. If I put the capacitor in, the whole thing could sound totally different. Okay. Good thing I thought of that. Great. Well, have a great day. Tomorrow I'll just plug away more on this, and eventually it's going to sound great. I'm sure of it. See ya.